Hi, welcome to AAT Tech Talk on microprocessors and microcontrollers. Subject code AEC013. Myself B. Devendar, rule number 436 from ECE 3D. Today we are going to discuss a topic in microprocessors and microcontrollers. Topic name: Register organization of 8086 microprocessor. The contents present in this PPT are: Introduction to computer processor, that is CPU, registers in 8086 microprocessor, general purpose register, segment registers, pointers and index registers, flag registers, status flag and control flag. Moving further. First topic: Introduction to computer processor, that is, a central processing unit is the hardware within a computer system which carries out the instructions of a computer program by performing the basic arithmetical, logical and input-output operations of system. This is a basic block diagram of computer. That is, first is a control signal and arithmetic and logic unit, ALU, main memory, auxiliary storage, output and input. Input is given to the main memory and certain logical and arithmetic operations are performed in ALU, and the control signal is given to the auxiliary storage to further store or retrieve the data, and the output data is given, output information is given. This is brief introduction to computer processor. Moving further. Registers that are present in 8086 microprocessor. The register set of 8086 can be categorized into 4 different groups. They are general data registers, or also known as general purpose registers, segment registers, pointers and index registers, status registers. Again, general data registers or general purpose registers, segment registers, pointers and index registers, status registers. Moving further. This block diagram shows the register organization of 8086. The general data registers consists of AX, BX, CX, DX. They are accumulator register, counter register, data register, so on. Segment register consists of CS, SS, DS, ES. A brief explanation of these are explained in the further PPTs. Moving further. General purpose register. The registers AX, BX, CX and DX are general purpose 16-bit registers. The register CX is used default counter in case of string and loop instructions. All data register can be used as either 16-bit or 8-bit. BX is a 16-bit register, but BL indicates lower 8-bit of BX and BX indicate higher 8-bit of BX. AX is used as 16-bit accumulator. The lower 8-bit is designated as AL and a higher 8-bit is designated as AH. AL can be used as an 8-bit accumulator for 8-bit operation. This is a brief overview of general purpose registers. Moving further. segment registers. Intel 8086 is a byte organized. Here 1 MB of memory is divided into 16 logical segments. Each segment contains 64 kilobytes of memory. There are 4 segment registers in 8086. Code segment register CX, data segment register DS, extra segment register ES, stack segment register SS. Again, code segment register CS, data segment register DS, extra segment register ES, stack segment register SS. Moving further, the code segment register CS. It is used for addressing memory location in the code segment of the memory where the executable program is stored. Data segment register DS. It points to the data segment of a memory where data is stored. Extra segment register. This also refers to a segment in the memory which is another data segment in the memory. Again, CS is used for addressing memory location in the code segment of the memory where the executable program is stored. DS points to the data segment of the memory where the data is stored. ES also refers to the segment in the memory which is another data segment in the memory. Moving further, stack segment registers. By default, the processor assumes that all data referenced by stack pointer SP and base pointer BP registers is located in the stack segment. SS, stack segment register, can be changed directly using pop instruction. It is used for addressing stack segment of memory which is used to store stack data. Again, by default, the processor assumes that all data referenced by the stack pointer SP and base pointer BP registers is located in the stack segment. SS register can be changed directly using pop instruction. It is used for addressing a stack segment of memory which is used to store stack data. Moving further, pointers and index registers. The pointers IP, BP, SP usually contain offsets within the code, data and stack segments respectively. Stack pointer SP is a 16-bit register pointing to program stack in stack segment. Base pointer BP is a 16-bit register pointing to data in stack segment. BP register is usually used for based indexed or register indirect addressing. The index registers are particularly useful for string manipulation. SI is used to store the offset of source data in data segment. DI is used to store the offset of destination in data or extra segment. Again, the pointers IP, BP, SP usually contain offsets within the code, data and stack segments respectively. Stack pointer is a 16-bit register pointing to program in the stack segment. Base pointer BP is a 16-bit register pointing to data in stack segment. BP register is usually used for based index or register indirect addressing. The index registers are particularly useful for string manipulation. SI is used to store the offset of source data in data segment. DI is used to store the offset of destination in data or extra segment. Moving further, status register. It determines the current state of the processor. They are modified automatically by CPU after mathematical operations. This allows to determine the type of the result and to determine conditions to transfer control to other parts of program. The status registers are of two types. They are conditional or status flag, control flag. Again, it determines the current state of processor. They are modified automatically by CPU after mathematical operations. This allows to determine the type of the result and to determine conditions to transfer control to other parts of the program. They are of two types: conditional or status flag, control flag. This gives an overview of control flag and status flag, which contains carry flag, parity flag, auxiliary flag, zero flag, sign flag, trap flag, interrupt enable flag, direction flag, and overflow flag. In these, 6 are status flag and 3 are control flag. The status flags are carry flag, parity flag, auxiliary flag, zero flag, sign flag, overflow flag. The control flags are direction flag, trap flag, and interrupt enable flag. Moving further, status flag. Carry flag CY. It is set whenever there is a carry or borrow out of the MSB of a result. CY is equal to 1. Carry is generated. If carry is generated, CY is equal to 0. CY is equal to 1, then carry is generated. If CY is equal to 0, carry is not generated. Parity flag. It is set if the result has even parity. If parity is odd, PF is reset. Auxiliary carry flag AC holds a carry after addition or a borrow after subtraction between bit positions 3 and 4 of the result. Zero flag indicates that the result of an arithmetic or logic operation, it is set if result is 0. Again, carry flag. It is set whenever there is a carry or borrow out of MSB as a result. If CY is equal to 1, carry is generated. If CY is equal to 0, carry is not generated. Parity flag PF. It is set if the result has even parity. If parity is odd, PF is reset. Auxiliary carry flag AC holds a carry after addition or a borrow after subtraction between bit positions 3 and 4 of the result. Zero flag indicates that the result of an arithmetic or logic operation, it is set if the result is 0. Status flag. Sign flag. It indicates the arithmetic sign of the result after an addition or subtraction. If S is equal to 1, the result is negative. If S is equal to 0, the result is positive. Overflow flag OF. A overflow condition indicates that a result has exceeded the capacity of the machine. A condition that can occur when signed numbers are added or subtracted. Again, sign flag SF indicates the arithmetic sign of the result after an addition or subtraction. If S is equal to 1, the result is negative. If S is equal to 0, the result is positive. Overflow flag OF. A overflow condition indicates that the result has exceeded the capacity of the machine. A condition that can occur when signed numbers are added or subtracted. Next, control flags. Trap flag. Debugging feature of the microprocessor. Interrupt enable flag. Interrupt controls operation. If I is equal to 1, the INTR pin is enabled. If I is equal to 0, the INTR pin is disabled. Direction flag controls the selection of increment and decrement of DI and SI registers during the string instructions. Thank you.